So this is one of the other ways the question can come in the examination room. They can give you a equation, as I did with the parallel lines. Give you an equation and ask you to find the equation of the line that is perpendicular to this line but is passing through that point. Well, obviously you know you need the gradient of the perpendicular line. So if two lines are perpendicular, the products of their gradient will be equal to -1. So, but I already said you can upturn and change the sign. Let's make this 2. So if the gradient of this line is 2, then if we upturn, it'll be 1 over 2, and we change the sign. So the gradient of the second line is -1 over 2 and x. So using these two, y is equal to mx plus c. M is, y is 1, m is, sorry, y is 1, m is -1 over 2, x is 4, right, plus c. That goes with that. We have 2, so is 1 equal to -2 plus c. 1 plus 1 is equal to c. C is equal to 3. So the equation of the line is y equal -1 over 2, x plus 3. And that's how you do that. Now, simultaneous equations. We have done a few ways of solving simultaneous equations, but now we're going to do this on the Cartesian plane. First, this is the graphical method. First, we're going to solve it one of the other ways. Let's use the elimination method. So 2x plus 5y is equal to 18, and 3x minus 2y is equal to -11. You can choose whatever method you want to, so I'm just going to do the elimination to get rid of it quickly. When you multiply, you'll get 6x plus 15y equal to 54, and 6x minus 4y is equal to -22. So now we have to observe the sign of this variable. Same signs means you have to subtract, subtract, subtract. And this will be 0, this will be 15, y minus 4y is equal to 54 minus 22. You'll get 19y equal to 76, and y is equal to 76 divided by 19. Y will be equal to 4. Now you can find the value for x. Substitute y equal 4 into any equation. Equation 1. So equation 1 is 2x plus 5y equal 18. Y is equal to 4, so it's 2x plus 5 times 4 equal 18. So it's 2x plus 20 equal 18. 2x is equal to 18 minus 20. 2x is equal to -2. X is equal to -2 divided by 2, which is equal to -1. So, what is the graphical method for simultaneous equations? What we're doing, we're putting these two linear equations on the Cartesian plane, and where they intersect, that is the solution. So if you were ever asked for the solution of the simultaneous equation, you're supposed to look to see where the lines intersect. So let's first put these two on the Cartesian plane. Well, we know how to do this already. We can use the table of value, or we can find where it intersects the x-axis, find where it intersects the y-axis, and that's how we know where it will. That's one of the ways in which we can draw the lines on the Cartesian plane. So it has to be in the form of y equal mx plus c. So 5y is equal to -2x plus 18, and y is equal to -2 over 5x plus 18 over 5. And so this is it's in the form y equal mx plus c, so we're okay there. This one, the 3 has to go over, so we have -2y. Note I didn't change my sign here. Is equal to -3x equal to -11. So then now the -2 goes over. So y is equal to minus 3 over minus 2x minus 11 over minus 2. So this y is going to equal to positive 1.5, 1.5x, and this is going to be equal to positive negative divided by negative to positive 5.5. So where does the first line intercept the y-axis? This is y is equal to minus 2 over 5x. 18 divided by 5 is 3, and 3 over 5. So this first line will intercept the y-axis at 3 and 3 over 5. This first line will intercept the y, this is the y-intercept. This second line, line 1, line 2, will intercept the y-axis at 5.5. Good, so now we just need to find where it's going to intersect the x-axis. So we say in the x-axis y is equal to 0. So we have 0 is equal to minus 2 over 5x plus, I want to put this back as 18 over 5. So now come over becomes, let's bring over this. So when this comes over, it becomes positive 2 over 5x is equal to 18 over 5. When we did algebra, we did simple equation. We said if you have an equation with fractions, we can multiply each term by the fraction, by the LCM. So this is 5 times 2 over 5x is equal to 5 times 18 over 5. The 5's will cancel. We have 2x is equal to 18. X is equal to 18 divided by 2. This line will intercept the y-x-axis at 9. Over here, we have to find the x-intercept. We say in the x-axis y is equal to 0. So 0 is equal to 1.5x plus 5.5. Take over to 5.5. So we have minus 5.5 is equal to 1.5x. Bring over the 1.5 now. So minus 5.5 divided by 1.5 is equal to x. So we divide those two, x is equal to 3.7. So the first line intercepts the x-axis at 3 and 2/5. This is a bit more than 3.5. And the second line is and 9. And the second line at 5.5 and 3.7. So let's draw that on the Cartesian plane now. Okay, so for the first line, it intercepts the y-axis at positive 3.3 and 3 over 5, which is 3.6. So as I said a little bit before, after 0.5, so 3.5 will be here, so 0.6 will be just above there. So this is where the first line intersects the y-axis, and then it intersects the x-axis at 9. So to draw this now, this line will look like this on the Cartesian plane. Remember, you have to always label your graph paper. So this paper should have been labeled at the top there, graph of the simultaneous equation, and you write the simultaneous equation. The second line intercepts the y-axis at 5.5, that's there, and the x-axis at 3.7. So this is 3, 3.5 will be here, 3.7 is a little bit past that. So this is where 3.7 should be, and when we draw this line, Right, we'll see that we have to label the line. This is y is equal to, was it 3 over 5x plus 18 over 5, and this one is y equal to, so we can see here that the lines intersect at x is minus 1, this side is minus, so this is minus 1, and y at 4. So the solution to the simultaneous equation is x is equal to minus 1 and y is equal to 4. And that's how you solve simultaneous equations using the graphical method. Now, if you're ever asked to, if you see a graph with some lines intersecting and you were asked the solution of those functions, you have to see, you write where the lines intersect. Okay, so our next video will be inverse function, composite function, and the others.